Good evening to all. Welcome to for 7 days training on project how to make the residential building. Analyze with the structural elements, slab, beam, columns, etc. Okay. Today we'll discuss about how to analyze the slab. First of all, what are the elements included in structural design? Our structural elements are our structural elements in RC framed structure is one is a slab, another one is a beam, another one is a column, another one is a footing, like a foundation. Okay, this is the main thing to create a create modeling, analyze, and design in framed structure. Okay, this is the main thing. Today we'll discuss about the slab part. How to analyze and design the slab. Okay, two things. One is the analyze, then how to take the values in is codebook. Okay, how to take the values in is codebook. The first step, the step one for slab design. Okay, the step one for slab design. Okay, step one means how to identify your slab. First step is a how to identify your slab. The first question is a how to identify your slab. This is the first question. There mainly the common slabs are one is a one-way slab. So okay, the one is the one-way slab. Another one is a two-way slab. This is the two common type of slabs are using in our building. Another one is a cantilever. Another one is a flat slab. There are so many of that. The mainly the two slabs are using in our RC design. One is a one-way slab. Another one is a two-way slab. What are the types in one-way slab? What are the types? This is a one-way slab. Different types in one-way slabs also. One is the simply supported one-way slab. The first one is a simply supported one way. This is a one-way identified. Next one is a continuous. The next one is a continuous one-way slab. There are two types are mainly using in our building. One is a simply supported one-way slab. Another one is a continuous one-way slab. The next one, the two-way slab. The two-way slabs are same type. One is a simply supported two-way slab. One is a simply supported two-way slab. Another one is the continuous two-way slab. Okay. Another one is a continuous two-way slab. There are two types of slabs in one way is a one is a only simply supported one-way slab. Another one is a continuous one-way slab. The two-way slab means the simply supported two-way slab is there. Another one continuous two-way slabs are there. There are four types in our slab. How to identify in our field? What is meant by one-way slab, simply supported and continuous? I simply draw one diagram. Okay, I simply draw one floor plan. I simply take my one floor plan. This is our plan. I take this one part. I take this one part. Like that. This is another one part. Okay, fine. I draw this one floor plan, and then go to I draw this. Then I draw this. So okay, this is another one. These are all another beams also. Okay, I provided this type of beams for this slab. This is a one building. First of all, I identify this is a one building. See, this is our area, veranda area. This is the assembly hall. Then this is a staircase room. Okay, this is our staircase. This is the office room 1 and office room 2. Okay, this is the office room 1 and office room 2. There are so many types of slabs are there. First of all, I mentioned this some distance. This is a 12 meter. This is a 4 meter. Okay, this is a 4.5 meter. This is a 5 meter. 5 meter. This is a 2.5 meter. This is a total 20 meter. I take the reference from book also. This is a plan. Okay. This is our first identification. This is one of the plan. This slab is a one-way slab. This is a one-way slab. Mention this one-way slab. One-way simply supported. Okay. This slab is a one-way simply supported. How to identify this slab? Ly by Lx. This is a formula. I take this, my slab is a 20 by 2.5 greater than 2. I simply take this one-way slab. This is my one-way slab. One-way simply supported slab, not a continuous slab. One-way simply supported. How to identify the simply supported? See this. This end are no continuous. This end also no continuous. This end also no continuous. So this is a simply supported one-way slab. See this. This is I identify my slab 1. The slab 1 is a simply supported one-way slab. Identify. This is a simple method to identify your building, how many continuous slabs and simply supported slabs are available. Next one, this is assembly hall. These are the so many continuous one-way slab. This is a continuous one-way slab. See this. Automatically, this is our continuous one-way slab. 1, 2, 3, 4. 4 continuous. This all name are temp. I simply given all names are S2. The S2 slab is a continuous one-way slab. See this. My continuous one-way slab. Okay, simply supported. First one is the one-way continuous. This automatically it go for continuously. The most of us the colleges building go for this slab, continuous slab. Mention this. See this in your college building or any building. The most of us buildings are you go for the second type, simply support. Some of the veranda, that type of areas will go for one-way simply supported. Okay, this is the first mention for your one-way simply supported. This is a one-way continuous. Then most of us staircase room. This is staircase room. The staircase rooms are provided for cap slab. See this elevation. This is a ground floor. This is a top floor, right? This is a top floor. This is a cap slab for my staircase room. The cap slabs are four sides are free, right? The four sides are free. So this is my two-way simply supported. Maximum the cap slab is a staircase room slab. Is a S3. This S3 is a simply supported. Okay. The four end are free. Simply supported two-way slab. Okay. Simply supported two-way slab. The maximum the two-way slab will be provided on this cap slab. The staircase room will be provided on this two-way slab. The next, this slab. This is a two-way slab also. This is a symbol. You mentioned this symbol. This is a two direction. This is a one-way slabs taken into one direction. The two-way slabs taken into two direction. This is a two-way slab. The two-way slabs, these are continuous two-way slabs. Is automatically it will be continuous. This is a one-way continuous. This is a two-way continuous. The two slabs are continuing. So this name I provided for S4. The S4 slab is a continuous two-way slab. See this difference, continuous two-way slab. This is a difference for your building. You take the one way, two way. The difference in one way also. One way simply supported slab, one way slab is comes continuous slab, and then you go for two way slab. The simply supported two way also there, and continuous also there. This next step. This is the identify your one way and two way slabs for your building. The next step, step 2. The step 2 is the first step. You provided the effective depth. Okay. Step 2. Next step, the first one, identify your slab. The next step is a effective depth. Okay. The next step is a effective depth. Effective depth is the D. How to identify effective depth? The effective depth based on your slab condition. You go for continuous slab, you go for simply supported, it will be different. For example, I take a simply supported one-way slab. Okay, simply supported one-way slab. My span by depth ratio is span divided by 20 into modification factor. My slab is a one-way continuous. Okay, my slab is a one-way continuous. My slab is a one-way continuous means both ends are continuous. You provided the span by 26 into modification factor. This is a difference for your condition. Okay. identify this. One way simply supported, use for the span by 20. Another one continuous means you go for span by 26. Okay, how to take this value from IS45 code books F2 depth formula? You go for page number 37, IS456. You go for page number 37. Once again, you go for, yeah, you go for page number 37. 37. This is the value for your simply supported or two-way or continuous. This is the major formula. This is my one-way simply supported span up to 10 meter. See, this is my simply supported. My span by depth ratio is a 20. I simply put on this 20 value for my area. See, this span by this span is continuous. I put this 26. Okay, this is the main ratio for your effective depth for this one-way slabs. Sometimes two-way slabs also different. Okay, the first thing is the how to take the values for your one-way continuous and simply supported. You take the simply supported slab for two ways and one ways. You go for 26. 20 for simply supported and continuous for 26. Okay, this is the main things for your taking the span by depth ratio. Next step is how to calculate the effective depth. Capital D. This I take this one way continuous. My slab is a one way continuous. The span divided by 26 into modification factor. Okay, you need you take the value for modification factor, then only you calculated the effective depth. Modification factor. How to calculate the modification factor? Anyone? How to calculate the modification factor? The simple two things will be needed. Okay, two things will be needed for your calculation for your modification factor. One is a steel stress. Okay, one is a steel stress. Another one is a percentage of tension reinforcement. Okay, another one is a percentage of tension reinforcement. The two things will be needed for calculated the modification factor. You go for simply IS 456 page number 38. The IS 456, the page number 38 will go for this slab portions. Okay, go for this slab portion. Will be calculated the modification factor. Okay, the first one is a percentage of tensile reinforcement. This is a tensile reinforcement. To calculate it, I tell about how to take the percentage of tensile reinforcement. Then how to calculate the steel stress service. You go calculate the FS. How to calculate the FS means steel stress. FS formula 0.58 into Fy. Okay, the FS means 0.58 into Fy. I simply provide 0.58 into 415. I simply calculated 240 Newton per mm square. I simply calculated my 240 mm square. Then how to assume your steel percentage? How to assume your tension steel percentage? Tension percentage. I tell some values. How to assume your percentage means based on your grade of steel. Okay, the based on your using Fe415 means you go for 0.25 to 0.45 percentage for Fe415. Using Fe415 means you assume the value in between 0.25 to 0.45. Okay, then you go for Fe500. You go for Fe500 means you assume this 0.2 percentage to 0.3 percentage. Okay, for Fe500. Fe500, then you go for next one is the mild steel 250. In 250 you go for 0.5 percentage to 0.9 percentage for Fe250. Okay, you how to calculate the modification factor? The first of all you calculated the Fs value. Fs formula is 0.58 into Fy. You calculated, then you go for how to assume the tension reinforcement. Directly go to PT percentage. You take this notes. Okay, You take this, the PT percentage for 415, using 415 grade, you go for 0.5 percentage to 0.45. You take this value for assumption as a zero point 0.3. Then you using 500 grade means you go for 0.2 percentage to 0.3 percentage. Then you using mild steel 250. You assume as a zero point 0.5 to 0.9 percentage. Okay. I simply take this 0.3. I am using simply using FE 500. Okay, FE 500 I'm using. Assume as a zero point 0.3. My grade is the, you taken this value 240 something. You calculated per 0.58 into F5. You go for, simply you go for IS 456. This is IS 456. This is a percentage of reinforcement. My percentage is a zero point 0.3. Your direction is a 240. FE 500 I'm using 240. Which place will be match it? You will take this value for modification factor. Okay, you take this modification factor for my value 1.4. It will be different for your grade of steel. Okay, using your grade of steel, the modification value will be different. Now it's clear the how to take the value for modification value, the based on your grade of steel, using Fe 415 or Fe 500 or Fe 550. Using this difference on your grade of steel, you calculated the modification value. This is the first step. Then you go for actual formula. You provided the modification for F tube depth, then use it for capital depth. Okay, you calculated the capital depth, and then next step, the first step 2 is over. The step 2 means you calculated the first step, identify. The second step is a depth. You simply calculated the modification factor. Then go for a total depth. You will be calculated the values. Okay. Then next step. The next step is a load. The next step, step 3 is a load calculation. What are the loads will be acting on your slab? Step 3. Okay. Step 3. The step 3 means loads. How many loads acting on your slab? Right, I write a one way or two way also. First one is a dead load. Okay, first load is a dead load. Next one is a live load. Live load. Next one is a floor finish. Okay, the floor finish. The three loads are mainly acting on your any different types of slab. Not only one way continuous or one way slabs or two way slabs. The three loads are main. One is a dead load, another one is a live load, another one is a floor finish. How to calculate the dead load? Dead load for your slab. Dead load is a self weight. I calculated my capital depth is my 130.13 into 25. 25 automatically I calculated my 3.25 kilonewton per meter square. Okay. Then how to take this 25 unit weight? How to take this 25? You go for IS 875 part 1. Okay, go for code book IS 875 part 1. This code book for self weight for this all materials. Okay, all materials, not only concrete, steel also. IS 875 part 1, it's mainly code book for self weight properties. All materials available. You go for brick, RCC, PCC, glass material, any material you go for IS 875. It's all will be available on this internet also. Okay, it's all will be available. It's a free, easily download and use it. Then next one is a live load. The live load is a different from different slabs. Okay, my floor slab is a 2.5. My corridor is a 3. My room is a 2. Then how to identify my live loads? To refer the code book IS 875 part 2, especially for live load is a IS 875 part 2. To refer the code books. Okay, for your live load you take that IS 875 part 2, especially for your live load. Then floor finish. The floor finish are same like that. Floor finish based on your floor, you provided the marbles or granite or tiles, that type of works. Okay, that type of works. How to take the self weight for your marbles, tiles and other? To refer the IS 875 part 2. Okay, you refer this IS 875 part 2, it simply take this values for your floor finish values. Now it's clear. The first step 3 is a load using for dead load, live load, floor finish. Three loads are there. Dead load and floor finish also based on the sulfate. It's taken from IS 875 part 1. Then go for floor finish is a same like a using a granite, marble or anyone. Is the same as a it's taken from IS 875, sorry, part 1, but live load only taken from IS 875 part 2. Okay, it's all the books are available. There are 5 parts are there. Part 3, part 4, part 5. It's another 3 parts are there. It's discussed about later. Okay. Then next step. The step 3 is over. If I calculated loads into factor of safety. Into 1.5 is the load combination. The load combination also code books are there. IS 875 part 5. Okay, the part 5 is a combination for your loads. IS 875 part 5, the part 5 is the combination for your loads. Our second step is the first step is identify your slab. The second step is based on your depth creation using the span by different formula. Then step 3 is a load combination, how to take the loads from code book. IS 875 part 1, part 2, part 3 and part 5 for your combination. Finally, I take this value for my total load is I take this my sulfate is a 3.25. Then my live load is a 2. My floor finish approximately take 1.5. This is my total load 5.75 kilonewton per meter square. So it's the area. So I provided kilonewton per meter square. Now it's clear, kilonewton per meter square. Then how to calculate the ultimate load into 1.5. So, okay, you provided the 1.5, you calculated the ultimate load. The next one, the next step, the step 3. The step 3 is a different. So okay, step 3 is, sorry, step 4. Next one is a step 4. Step 4 is a different. The step 4 is a different for one way slabs and two-way slabs. Okay, one-way slab and two-way slab is a different. The step 4 is a one-way and two-way slabs are different. Okay, how to take the what is the step 4 is a bending moment calculation. Okay, the bending moment calculation. The step 4 is a bending moment calculation. So okay, this is the main things for your calculation is a step 4 is a bending moment calculation. Now it's clear. Step 4 is a different. The step 2, step 3 are common. Span by depth ratio compare with one way and two way. The loads are common, but the bending moment are different. One way slab and two way slab also. Continuous and difference also. The first one way. The one way go for simply supported. Simply supported one way slab. First of all, simply supported one way slab. How to calculate the bending moment? WL square by 8. You calculated the bending moment for your simply supported one way slab. Okay, simply supported, this is the method. Then how to calculate the continuous one way slab? Continuous one way slab for your bending moment. Continuous one way slab, you go for IS 456. Okay, go for bending moment calculation for one way slab means you go for continuous page number 36. IS 456, you go for page number 36, table 12 for your bending moment for your one way continuous. Okay, not a simply supported, one way continuous. This is the bending moment formula for your one way continuous slab, the span moment and support moment. Okay, this is the main thing to calculate at the span moment. This is a bending moment formula, bending moment coefficient. This is the method to calculating the one way continuous slab for your bending moment calculation. Okay, this is a formula. This is support moment and span moment. I tell about first of all I draw a simple diagram for one way continuous. Okay, one way continuous. I simply take that this is my slab. Okay, I simply take that this is my slab. I split it into 4 portions. Okay, I simply split it into 5 portions. See this. This is my one way continuous slab. 1, 2, 3, 4, 5. Okay, this is a 1, 2, 3, 4, 5. 5 slabs is there. 5 slab. This is my support. A, B, C, D, E, F. Okay. A, B, C, D, E, F is the 6 supports. 6 supports. Then this is span. Center. This is span portion. This is center portion. Okay. Support portion is the A, B, C. I simply draw this A, B, C, D, E, F. Okay. This is a B, C, D. This is A, B, C, D, E, F. These are all support moments. Okay. These are all support moments. Okay. Identify this. These are all support moments. What is mean by span moment? This is the span moment. 1, 2, 3, 4, 5. Identify this. This is a method to identify your span moment and support moment. The A, B, C, D, E, F are all a span moment. Okay. The 1, 2, 3, 4, 5. These are all span moment. A, B, C, D, E, F are support moment. This is the main condition for your one way continuous bending coefficient. See the support moment, span moment. The support moments are A, B, C, D. The span moments are 1, 2, 3, 4. I simply draw this bending moment diagram for this one way slab. Okay, one way continuous. See this. This is our bending moment diagram for this one way continuous. See this. This is the one moment have. I simply draw this one large diagram. This is our portion, right? Some I put only 4. Okay. See this. This is a sorry. This portion is a no moment. It's starting from this area only. This is a no moment. It's a 0 moment. So it's starting this area only. Okay. This area. See this. This is starting point is a 0. Then middle have some moments. This support have some moments, right? Support. Then is the center portion. Span moment is there. Span moment. Then support moments are there. This is the support moment. This is the span moment. First of all, you identify this. What is mean by span moment and what is mean by support moment. Okay. Identify this support moment and span moment. Now it's clear. Which portion is a span moment, which portion is a support moment. Okay. So next of all, how to calculate the bending moment formulas. How to calculate the bending moment formulas. Another one method. This is our IS 456. The mid span and interior span. This is the next end support. This is the interior support. Okay. Next end support. This is the interior support. Inner span. Then how to calculate it? The go for your formula. The first step, I simply draw this. I simply go for I simply draw this. This 1, 2, 3, 4, A, B, C, D, E, F. Okay, F. The first span. This is I mentioned this A, B, C, D is the support. A, B, C, D, E, F. Okay, the spans are 1, 2, 3, 4, 5. The first span is a center span. AB is the interior span. This is the outer span. Okay, this is the outer span. Identify this. AB center is the outer span. The next one, the B support is the second support. The B support is a pentulate support. Okay, the penultimate support. The B support is a penultimate support. You go for BC. The BC is a inner span. BC is a inner span. Okay, BC is a inner span. Then C is a intermediate support. C is the intermediate support. See this. Now it's clear. The AB center is the outer span. Then go for BC center is the inner span. Then B is a pentulate support. Then C is the intermediate support. Same like this, the same equal span. So same like this, same procedure will be follow on this side also. Then first of all, the outer span. Outer span formula. The outer span you will be calculated for your bending moment for you. First thing, you do not combined with the bending moment and sorry, live load and dead load. Is a live load and dead load are separate formula is there. This is a dead load formula, then live load. You go for simply supported one way slab, you combined with the dead load and live load. But you go for one way continuous, will be used on separate portion. Dead load is a separate formula is there. You go for live load is a separate live load is there. I simply go for, I take this bending moment calculation for my outer span. This is my outer span. AB interior outer span. The outer span, my live load formula is the 1 by 12 plus 12. Then go for dead load. My dead load is a plus 1 by 10 for my bending moment formula. The next one is a penultimate support. This support, B support. How to calculate the B support bending moment, B support. Then go for your B support live load formula is a minus 1 by 10. Your dead load formula. Dead load is a minus 1 by 12. The next support is a inner span moment. Inner span moment. This is our inner span. See this is our inner span moment. How to calculate the bending moment for inner span? The live load is a 1 by 12. Then dead load is the 1 by 16. Next one is a intermediate support. This support, how much bending moment will be acting on this intermediate support. Okay, intermediate support. The live load, you go for minus 1 by 9. Dead load, you go for minus 1 by 12. This is the totally the 4 bending moments are comes from one way continuous for equal spans. You go for simply supported one way, it's only one bending moment, it's go for WL square by 8. But you go for continuous, the four bending moment will be calculated. Span moment and support moment also. This is the outer span. This is the outer span. You search it. This is our span moment. You go for this is the outer span. So this is plus 1 by 12 plus 1 by 10. This is plus 1 by 12. This is the intermediate span, inner span. 1 by 12, 1 by 16. Inner span. See this automatically. This is our inner span. 1 by 16, 1 by 12. Same as our shear force also. Shear force coordinate also. It will be different. Now it's clear how to calculate your bending moment for one way. Simply supported is a single formula, but you go for one way continuous means you will be calculated the four moments. Okay, you will be calculated the four moments like outer span, ventilate support, and inner span, then interior support. Then you calculated the all the AST values for your one way slab. You ask that the four moments are there, which moment will be taken? You compare with the four moments. Okay, the first moment will be 15, the second moment 17, the 21 and 30 something is there, the four moment value. Which one is higher? As 30 is a higher, you take this higher moment. Okay, the higher moment will be calculated for your ASTs and all the values. Okay, now it's clear. The one way simply supported means you go for your simple procedure, and you one way continuous means you calculated the outer span moment and then inner span and support also. You differentiate between live load and dead load formulas for one way. Then you go for two way. The next step 4 is a two-way bending moment. This is a understand. This is a one way continuous bending moment formula. Then go for next step. The step 4 common to two-way. Two-way two-way slab bending moment. Okay, two-way slab bending moment formula. First of all, you go before you go for bending moment formula, you know that edge condition. So okay, you properly know that edge condition for your two-way slab. Okay, two-way slab for your edge condition. You simply go for IS 456 edge condition, page number 91. Page number 91. You properly understand this edge condition for your two-way slab, then easily to calculate the bending moment diagram, bending moment calculations. Okay, this is also inner span and inner moment also. Then I go for IS 456, the page number 91. Okay, I simply go for this page number 91. This is our inner span moment and shorter span and shorter support and longer span and longer support also. There are four moments coefficient are there. This two-way slab. One is a shorter span, the shorter span coefficient, and then mid span also. Support and span condition. There are four moments are in this two-way slabs. The first you know that edge condition. First you know that edge condition for your two-way slabs. First you know that there are so many edge conditions are there, right? There are so many edge conditions. One is the interior panel, one short edge is continuous, one long edge is continuous, right? What is mean by short edge continuous, one discontinuous edge continuous? You thoroughly know that. Okay, first of all I tell about the edge conditions. Edge condition, so first of all, see, this is a one of the slab. This is slab. This is a 4 meter. This is a 3 meter. Okay. This symbol is a discontinuous. This symbol is a discontinuous. Okay. This symbol is a discontinuous. This arrow mark is a continuous. Identify this slab. This slab is a 1 edge continuous. Okay. This is a 1 edge continuous, but one short edge or long edge. This is a 3 meter. So short edge. One short edge continuous. Okay, one short edge continuous is automatically the formula will be available. The one short edge will be continuous. The one long edge will be discontinuous means then other formulas. Two adjacent sides discontinuous, same like that. Two adjacent side means this is a 4 meter, this is a 3 meter. This side and this side. This is two adjacent sides are discontinuous. Two sides are continuous. This is the adjacent sides. This is the two adjacent sides discontinuous. Okay. Now it's clear. This is the two adjacent sides. Opposite or not opposite, opposite, adjacent sides. Different values in opposite adjacent side. The next one. The next one is the next one, two long edges discontinuous. The next one is a two long edges discontinuous. See this is our one of the slab. This is a 4 meter, 4 meter. This is a 3 meter, 3 meter. Two long edge discontinuous. See this long edge discontinuous. This is a two short edge discontinuous. See this is the two long edge discontinuous. The 4 meters is discontinuous. So two long edge discontinuous. This slab same like that. This is the 4 meter. This is a 3 meter, 4 meter, 3 meter. This slab is a simply draw this. The 3 meter edge is discontinuous. The 4 meter is a continuous. So this is a two short edge discontinuous. See this two short edge discontinuous. Then you take this value for alpha x and alpha y. This is the edge conditions. Next one, 3 edge discontinuous, one long edge continuous means this 4 meter, 3 meter, this is a 3 meter, 4 meter is there. See this automatically the three edges are discontinuous. The 4 meter only continuous. This is a method. Three edges are discontinuous. One long edge continuous. Okay. This is the main things to calculating your edge conditions. Okay. Now it's clear. This is a method to calculating the edge conditions for your building. Then you take the values for your starter span long and all the things for your calculation. Now it's clear how to calculate the edge condition. Then you go for IS456. IS456. This is the formula for creating your moments mx direction, my direction for two-way continuous. Okay, this is the formula for two-way continuous. Then you go for how to identify this mx and my value. This is the alpha x and alpha y value. The alpha x and alpha y based on two conditions. Okay, alpha x and alpha y are two conditions. Alpha x and alpha y are two conditions. One is the edge condition. Another one is the Ly by Lx condition. One is a based on edge conditions. Okay, one is a based on edge condition. Another one is a Ly by Lx conditions. Okay, my slab is a two edge discontinuous, two adjacent discontinuous, two adjacent discontinuous. My Ly by Lx value is a 1.1. I take my short span moment and a longer span and a support moment also. The four moments I will take that shorter span and longer span. Also, it's a 4 moment. It will be take that for my building. Shorter span and longer span moments also. Shorter span and longer span. See this, the edge first is the main important thing is the edge condition. Another one is the Ly by Lx. Okay, another thing is the Ly by Lx. I simply go for page number 91. Okay, the 91. How to calculate the span moments means the first of all you will be calculated the Ly by Lx. This is the main thing, Ly by Lx. My distance is a Ly by Lx is a 1.1. Then you go to edge conditions. Then you go for edge conditions. My edge condition is a two adjacent sides. This is my two adjacent sides are discontinuous. My value, see this value is 1.1. You take this my negative moment continuous edge and mid span. This is span moment. This is shorter span support moment. Okay, this is a support moment. This is span moment for short edge. I need a long edge. This is a longer span coefficient. I simply go for adjacent side. Then will be take the continuous edge and mid span moment also. Will be take this for this continuous slab. Once you know that Ly by Lx, then you will be known that edge condition. This is a main important one. You know that edge conditions and span Ly by Lx ratio. The next one, it will be simply calculated this continuous slab. Then how to calculate the simply supported? The simply supported also given in the bottom of the table for your building. Okay, this is the main method to calculating or simply supported. Another, then one way slab. This is a difference. You go for one way slab, you will have that continuous. You go for continuous two way slab means you go for that formula. You will be calculated this moment. Then go to simply supported. You go for this bottom. You calculated the simply supported cap slab. That type of slabs you will be take that values. Okay, now it's clear how to calculate the bending moment for one way slabs and two way slabs also. Is the formula will be different. The step 4 is the important one, how to calculate the bending moment formulas for your one way continuous and two way continuous for this all the areas. Okay, the next step is a step 5. The step 4 is the bending moment. Now it's clear how to calculate the bending moment values for your buildings. This is a method to based on a one-way slab and two-way edge conditions also. The next one, step 5 is the AST values. The step 5 is the AST value. You take this easy one. Okay. You directly take this bending moment, then you calculated the AST values. The step 5 is the reinforcement values, reinforcement calculations for your slabs. Okay, that take your moment value, then calculated the AST values. Okay, then you calculated the AST values for your buildings. This is the main important. You simply click this moment value, then calculated the AST. Then you will be go for this reinforcement also. The next one is a step 6. The next one is a step 6 checks. Check what are the checks are, you will be go for that. One is a deflection is a main important checks for your two-way slabs and one way slab also. Next one is a shear check, and then next one is a development length. Okay, the main things you go for your slab is at 30 feet after, then only you check for shear check. Otherwise you go for deflection check only. Okay, you necessity for deflection checks only. How to check this deflection values for your check? The check for deflections values, the first of all you starting you assumption some values, right? Initially you assume the pt percentage of value, 0.3 percentage value. You check for deflection, assumption value is the 0.3, but the actual value is the 0.23. So it's a deflection check is a safe, but is sometimes my assumption value for zero point 0.3, but my value is a 0.34. To redesign it, this is the main thing for your deflection check also. This is the main thing for your deflection check for first check. first check is the tension percentage check for your deflections. Okay, first check is a tension deflection. The first check, second check for deflection is a depth. Okay, depth. I calculated my depth is a 130 mm, but I calculated based on my 0.23. Actual my assumption percentage is a 0.3, but the actual percentage is a 0.23, right? 0.23, I calculated my depth for my 0.23. Finally I calculated my depth is a 90 mm. Okay, calculated my 90 mm, so it will be safe. The mainly the deflection will be checked for your percentage of tensile reinforcement and then depth of your reinforcement. Okay, this is the main things for your slabs. Okay, this is the main things. First one is a deflection. Another one is a which one? Depth of your slab. This is the main things for your area also. Okay, the two checks are main. One is the deflection. Another one is the deflection and depth checks also. This is the procedure. Maximum the 5 procedure will be follow. One is how to identify your slabs and others, then deflection, bending moment and others at all. Okay, now it's clear how to identify your reinforcement and AST bending moment values. So finally you calculate a check, then you go for your site execution also. The next simple steps. Then how to identify your some design methods. Their design methods are available to design your slabs. Okay, some design methods. I tell about the 4 methods to using to design your slabs. There are 4 methods to designing in your slab. One is the using IS code coefficient method. This is the first method. The next method, the second method is the exact analysis method. The second method is the exact analysis method. Then third method. The third method is the approximate method. The third method is the approximate method. Then fourth method. Then fourth method is the very approximate methods. Okay, then fourth method is a very approximate method. There are 4 methods are available to design in your slab. Our methods are using coefficient methods. Okay, our methods are using coefficient method. There are 4 methods are there. One is a IS code method, the another one is a exact analysis, another one approximate method, the next one, the fourth method is the very approximate method. Very approximate method. Our using method is the first method. IS coefficient methods are using for this method. The next one is the detailing of reinforcement for slabs. Detailing of reinforcement for slabs. Reinforcement for slab. The next step is a detailing. You step 7. The step 7 is a you finally check your deflection, then go for detailing procedure. Okay, the next step is a detailing reinforcement for your slabs. Okay, the next check is a detailing reinforcement. There are two types of span. One is a main reinforcement, another one is a distributions. Okay, one is a main reinforcement for your slab, another one, second one, the second one is a distribution reinforcement, another one is a distribution reinforcement for your slab. There are two types of slabs are available. One is the main reinforcement slab, another one is a distribution reinforcement. There are two types are there. One is a main reinforcement, distribution reinforcement. So what is meant by the main reinforcement means this is the resistant design moment. Okay, resistant design moment or main reinforcement. Simply tell about resist the design moment. Okay, this is the design moment. This is the design moment known as main reinforcement. Okay, this is the design moment is known as main reinforcement. Then you go for distribution. Distribution means the steel distribution load proper direction. Load proper directions. Okay, load proper direction, load proper direction, then zero moment. Okay, zero moment, zero moment is known as distribution reinforcement. Okay, distribution reinforcement is the main reinforcement. This is the design moment is the main reinforcement. Load direction is a distribution reinforcement. There is a zero moment. Okay, that is a zero moment load direction. The next one, the simply tell about the one-way slab. The one-way slab, the main steels provide shorter direction. The main steel provides shorter directions. Okay, shorter direction. Then distribution provides longer directions. Okay, distribution provide longer direction. This is a simple example for your reinforcement, main reinforcement and distribution reinforcement. It's go for detailing. It's a easy one. One is the main reinforcement, another one is a distribution reinforcement. The main reinforcement is go for only resisting on design moment. Then distribution, it will be follow the zero moment only on load direction side. Okay, only on load direction side. The next one you provided the one way slab means the main reinforcement will provided on shorter direction, the distribution will be provided on longer directions. Okay, it's a clear. You go for detailing, one is a main reinforcement, another one is a distribution reinforcements. It's provided on the shorter direction and longer direction for your slabs. Okay, now it's clear how to provide the reinforcement detailing for your one way continuous and then distribution rods for your slabs. The next thing, the next one is the what is the checks for your slab condition. Next step is the checks for your slab conditions. Checks for slab conditions. Checks for your slab conditions. What are the checks are available in this slab condition? Basically, I tell about first one is the main bar and distribution bar. The minimum reinforcement for FE415 for slab. The minimum reinforcement is 0.12 percentage for FE415. Okay, the minimum reinforcement for FE415. Then minimum reinforcement for 250 is a 0.15 percentage. Okay, is it 250 to using 415, the minimum reinforcement for steel is a slab is a 0.12. You go for this 250, the 250 you go for 0.15 percentage. This is some conditions using for your slab conditions. One way and two ways the same one. The minimum percentage is a 0.12 percentage for 415, then 0.15 percentage for your 250 grade. The next one, the second step, this is the first one, the minimum percentage. Next one, diameters for main bars. Okay, then diameter for diameter for main bars. Then diameters and main bars will be provided for 8 mm or 10 mm for Fe415. Using grade Fe415, you provided the 8 mm or 10 mm. You using 250 mm, you provided the 10 mm or 12 mm. You for Fe250. So okay, now it's clear. Using for main bars 8 mm or 10 mm for 415, and other than 10 mm or 12 mm for Fe250. Okay, Fe250. It's clear. This is the first check is a minimum reinforcement is a 0.12 percentage. This is 0.15 percentage. Dia for main bar is a 8 mm or 10 mm for Fe415, and then 250 is a 10 mm or 12 mm. This is the main checking for your slab designs. Okay. The next one, next check the bars. Using the bars not exceed, using the main bars, the dia of the bars not exceeding 1/8 thickness of the slab. Okay, 1/8 thickness of the slab. Using your bar for assumption, I am using 8 mm dia for my slab. Okay, dia for my slab. The simple formula is a d by 8. D is a total thickness of the slab. Okay, D is the total thickness of the slab. Thickness of the slab. For assumption, I provided the is mm. The unit is a mm. I provided the 130 mm divided by 8. You provided the 16 mm dia. The maximum limit is a 16 mm bar. Will provided for your slab, but I provided the 8 mm dia. Now it's clear how to check the your bar dia is the correct maximum or minimum. Okay, this formula is a D by 8. D is the total thickness of the slab by 8. D is my slab thickness is a 1 by 130 is a mm unit divided by 8. My maximum, my bar size is a 16 mm dia. So my bar size I provided 8 mm dia. It's a safe. Next step is a safe. The second step and the third step is a 1 by 8. 1 by 8 is a D by 8 is a thickness maximum dia of the bar. The next one is the maximum spacing for main bars. Next one is the maximum spacing for main bars. Maximum spacing for main bars is a S max. You calculated distance or 3D, 3 into dia of bar or 300 mm. Okay, 300 mm, whichever is smaller, you will be take this maximum spacing for your main reinforcement. Okay, main bars, main bar, whichever is the smaller. Then go to distribution. Then go to distribution same as the you calculated formula. Then go to 5 into D or 450 mm, the maximum 450, whichever is smaller, you will be take the maximum spacing for your distribution reinforcement. For your main bar, 300 is a maximum, your distribution is a 450 is a maximum. These are the main checks for your slabs. The next one is the minimum spacing for your reinforcement distance. Minimum. This is a minimum spacing. The minimum spacing is a 75 mm. Okay. The maximum spacing is a 450 for distribution, 300 for mm. Then minimum is a 75 mm or 100 mm. Probably 100 mm is a minimum distance for your slabs. Okay. Then cover. The cover is based on your exposure condition. Okay. The next is a cover. You provided the normal 15 mm or 20 mm, otherwise based on exposure conditions. Okay, exposure condition, you will be change the cover also. This is the basic checks you will be needed for your conditions. Okay, the slab, the first one you calculated the span by depth ratio, then you go for load, you take the code books, then bending moment for different for your one way and continuous two ways. You calculated the edge condition for short edge, short support and simple support, then you will be calculate the AST, then calculated the deflection checks also. Will be calculated the deflection check, percentage of tension reinforcement and depth of the slab. The two checks are main. Then detailing of reinforcement. The next step is the detailing of reinforcement. You provided the shorter span and long main reinforcement and distribution reinforcement for your building. The steels are provided, the moment will be main reinforcement, zero moment is a distribution reinforcement. This is the main one. And then there are four methods are using, already tell about the IS coefficient methods are using for our conditions. Okay, then these are the some checks for your simple checks, the minimum conditions, dia bars and the thickness checking and otherwise as per IS 456 conditions. Okay, this is the small introduction about the slab conditions. Is the minimum thickness and so many things are there. This is the some basics values. You will take this the type of basics values. You will design the whole things for slab design for manual calculations. Okay, this is a manual calculation. Now it's clear how to calculate the manual calculations for your manual calculations. I tell about formulas how to take this and others. Okay, the next step is the next one. I tell about how to calculate the load distribution for one-way slab. Okay. And the next step is I tell about the load distribution. This is a simple one. I tell about the load distribution. Load distribution for one-way slab. Okay. I tell about the simple method to load distribution for one-way slab. I take this one-way slab. Okay. I take this one-way slab. This is our one-way slab. First of all, you know that yield line theory. All of us know that yield line theory. Yield line theory. The yield line theory is a load pattern, load cracking pattern. Okay, this is our yield line theory. The yield line theory is a load cracking patterns. Okay, I draw this my two-way slab is a yield line is a two-way slab. Two-way slab is a this is the yield line theory for my two-way slab. Then I draw this one-way slab. Then I draw this one-way yield line theory. This is the line for yield line. The one-way slab, its load transfer into two direction, but two direction based on this yield line theory. Two direction, okay. Two direction load transfer. One-way slab is a two direction, but you go for two-way slab. Two-way slab, the load transfer to four directions. Okay, load direction to four direction based on your yield line theory. You study the yield line. This is the yield line pattern. The one-way slab, the load transfer into this two sides. Okay, this is for assumption. This is a one-way slab. Ly by Lx is simply this is a 12-meter span. This is a 4-meter span. Automatically greater than 12. This is a 12-meter. This is a 4-meter. The one-way slab only load transfer to this two longer span only. Then two-way slabs, the two-way slabs are load transfer to four direction. The two-way slabs is automatically our two-way slabs are is a rectangular portion. This is a triangular portion. This is a two-way slabs are load transfer into four directions. Okay, this is a different. One way is a direction into two direction load transfer. The two way is a four direction. The first of all, how to calculate the load distribution for one way slab. See, this is a one way slab. This is our yield line patterns. Okay, this is a yield line pattern. This is only I take this only single slab 4 into 12. This is my live load. This I take this my live load for my 0.75. Then I take this my dead load is a 130 mm thickness. Then floor finish. I take this my floor finish is a 2.25 kilonewton per meter square. This is also all of us kilonewton per meter square. These loads are acting on this one way slab. Same like this live load is acting. So 0.75. The dead load also 130 mm thickness. Then floor finish. The floor finish also 2.25 kilonewton per meter square. The next step, it will be simply calculated the simple steps only. The simple methods will be calculated the load distribution for one-way slabs. I will draw this one-way slab. This is automatically this is our one-way slab. Then I draw my yield line theory. This is center portion. This is center. This is a dot line. This is a 4 meter. This sorry, I draw another one. This is our yield line theory. This is our 12 meter. This is our 4 meter. Okay. Loads is a live load is a 0.75. Then dead load is a 130. Then floor finish is a 2.25. It is a kilonewton per meter square. The dead load is converted 0.13 into 25. You provided the 3.25 kilonewton per meter square. Okay. What are the load acting on this your slab? The dead load is a 3.25. Live load is a 0.75. Floor finish is a 2.25. All are kilonewton per meter square. Okay, all are kilonewton per meter square. Then next step, this is I converted into two. I calculated by two. One is a dead load, and another one is a one live load. Okay, this is my I created this my own method. Once you check directly go to stat, you check this value and stat values are same. Okay, I compare with the stat also. This is my own method. You will be check it any doubt you will check it the same one slab. Then you go for one way slab, and then you draw the same slab, you will be check it. Then first step, the dead load. How much dead load will be acting on this in this beam? Okay, how much dead load acting on this beam? Our dead load is a sulfide. Our dead load is a delphide 3.25. Okay, 3.25 kilonewton per meter square. The first of all, a dead load, I calculated my volume for my slab. Okay, dead load I calculated for volume. My volume is a total 12 into 2. 12 into 2 means 12. Anyone? 12 into why is a distance, this distance is a lx is a 4, right? But I provided the 2 is a half of the load only. So you did not understand means you simply go for 4 by 2. You simply put the 4 by 2 is a 2. So 12 into 2, 12 into 2 is a 24, right? 24 meter square. Then you go for convert into volume. 12 into 2 into our thickness 0.13. You simply calculated the volume. Our volume is a 3.12 3.12 meter cube. Our volume of the concrete is a 12 into 2 into 0.13. You simply calculated the 3.12. So okay, 3.12 into 25. How to calculate the total weight of our building beam? This is a total beam is a 12 meter. How to calculate the total weight of your beam? Volume 3.12 into 25. So 25 means our unit weight. I simply go for 3.12 into 25. Our total weight is a 78. Okay, I taken into kilonewton. 78 full weight. This is a full weight. Then how to calculate the per meter? Per meter means all weights are per meter. 78. Our total length of the beam is 12. I simply put the 12. I simply go for 78 divided by 12 is a per meter is a 6.5 kilonewton per meter. Okay, 6.5 kilonewton per meter. This is slab is a 12 meter. I simply draw this 5 kilonewton per meter. It's a dead load. I calculated only dead load. The next one I calculated the live load. The next load is a live load. I calculated my live load. Live load is converted into area. Same portion 12 into 2. So 24 meter squares. Okay. So 24 meter square. 24 into our total live loads, area loads. The floor load also area. So I simply provided that my total live load is a 0.75. Then I take the floor finish also. I take my live load then plus floor finish. My load is a 3. So I provided the 24 into 3. It's a 72. This is 72 total load divided by per meter is a divided by 12. Divided by 12 is your per meter is a 6 kilonewton per meter. Understand? Your total live load plus floor finish is a 6 kilonewton per meter. This beam 6.5 is a dead load. 6.5 is a dead load. 6 is a live load plus floor finish. The total load for your 12 meter beam is a total load for your beam is a total 6 plus 6.5, total 12.5 kilonewton per meter. Now it's clear how to acting on the beams for your 12.5 kilonewton per meter for your beams. Okay, now it's clear how to calculate the load calculation for your one way slab. First of all, you calculated the dead load, then go for your volume. You calculated the volume, then you into unit weight, then divided by 12. It takes the per meter 6.5. Then you calculated the live load is converted into area 24. Then go to total load is a 2.5, 2.25 is a floor finish, 0.75 is a live load, total 3 is a total load divided by per meter, total 6. Okay, then I take finally I taken my total load is a 6 plus 6.5 is a totally it's acting on this beam is a 12.5 kilonewton per meter total load. Then this is on continuous slabs are going on this side. This slab is half of the portion is there. This slab total 20 12 plus 24 25 kilonewton per meter total load for this areas. Okay, now it's understand how to take the values for your slabs, and how to check this, how to calculate the volumes and others areas, all of us. Okay, so okay, fine. Now this today's section I will be completed now itself. I hope you understand, you will know something about the slabs, how to calculate it, the formulas and all the things also in this today's class. This is the basic method to calculating the like a forms and all the things also. Okay, now it's clear how to calculate the volumes, then check the values, all of us. Okay, I will put the chat box in this Google form. Please fill the ordinance. Then you will take the ordinance and feedbacks also for your daily section. It's needed the 80%, it will be mandatory. Okay, then you provided the certificate for this course. Okay, important. I will put the feedback link for this chat box. It's only validity for 10 minutes. Please fill this feedback form. Feedback and attendance form also. It will take the attendance 80 percentage attendance. At least you attended this 6 days or 5 days continuously. Then only provided the certificate. You are simply attended 3 days or 2 days, will not provided the certificate. Once you attended 5 days to 6 days, you'll be give the part certificate for this course also. Okay, fine. Now itself I complete this section. Any doubt will be put in chat box. Otherwise, we will meet on tomorrow itself. Please fill the feedback form and others also. It's validity only for 10 minutes. Okay, thank you. Or any doubt, we'll put the chat box.